Hello viewers, and welcome once again to my YouTube channel. In this video I am going to show that the whole angle from here to here is equal to 90 degrees. How do I go about that? The first thing I am going to do is to connect all these points to the center of the circle, and after that I am going to find the angles inside those triangles. I will start by finding the angle in the triangles here. Do you know that this triangle is isosceles? The reason is simply because this radius is the same as this radius, and for an isosceles triangle the base angles are what? Equal. So if the angle here is 70 degrees, the angle here is equally 70 degrees. Let's find the angle that this chord subtend at the center. We know that sum of angles in a triangle is equal to 180 degrees. So if we add these two together, it will give us 140 degrees. Subtracting that from 180 degrees gives us the angle at the center as 40 degrees. Next, what does these two signs tells us? The length of those chords are equal. Do you know that equal chords subtend equal angles at the center? If this chord subtend an angle of 40 degrees at the center, this chord will also subtend the same angle of 40 degrees at the center. Next, let's find these two angles. That triangle is also what? Isosceles, because the radius there have the same length. So subtracting 40 degrees from 180 degrees gives 140, and then sharing 140 degrees into 2 gives the angles here as 70 degrees each. Next, let's come to this angle. We're having 65 degrees there. That triangle is also isosceles, just like others, and base angles are what? Equal. So if the angle there is 65 degrees, the angle here is equally 65 degrees. Let's find the angle that this chord subtend at the center. 65 plus 65 is 130 degrees. Subtracting that from 180 degrees gives the angle at the center as 50 degrees. These two chords have the same length. Equal chords subtend equal angles at the center. So if this chord subtend an angle of 50 degrees at the center, this chord will also subtend the same 50 degrees at the center. Next, let's find these two angles. Subtracting 50 degrees from 180 degrees gives us 130 degrees, and then sharing 130 degrees equally between these two angles gives each of them as 65 degrees. Now we are to find the value of x. The next thing I shall do is to connect this point to cut through one of the angles at x. Also connect this to cut one of the angles at x. Can you now see that we are having a cyclic quadrilateral here? For a cyclic quadrilateral, the four ends touch the circumference, and for a cyclic quadrilateral, the sum of the opposite angles is equal to what? 180 degrees. So the whole angle here is 135 degrees. 70 plus 65 is 135. 135 degree plus what will make it 180 degree. 180 minus 135 gives the whole angle here as 45 degrees, because sum of opposite angles of a cyclic quadrilateral is 180 degrees. Now let's get these two angles so that we can add to this to get the whole value for x. Let's start by getting the angle here. Come to this arc. Can you see that this arc subtend an angle of 40 degrees at the center? What angle will that same arc subtend on the circumference here? Do you know that the angle that an arc subtend at the center is twice that which it will subtend on the circumference? So if this arc subtend an angle of 40 degrees at the center, that arc will subtend an angle of 20 degrees on the circumference. The same thing applies here. If this arc subtend an angle of 50 degrees at the center, the same arc will go on to subtend what angle on the circumference. Dividing 50 by 2 gives us the angle it subtends on the circumference as 25 degrees. So now you can see that the value for x is the sum of these three angles. 25 plus 45 plus 20 degree is equal to 90 degrees. Hence, the angle in a semicircle is always 90 degrees. Thank you for watching. For more exciting videos like this, kindly subscribe to my channel and share my videos.